this video, we're going to learn about for loops. We're going to use an example from math. There's a formula that tells you what the sum of 1 plus 2 plus 3 plus ... plus n is. The formula is n times n plus 1 divided by 2. But what if we weren't sure that that was the right formula? How could we check? We're going to use r to check. Using what we learned about functions, we can easily create one that computes this sum. I'm going to call it s underscore n. The function is compute underscore s underscore n. I'm defining it. It takes a value n, it creates a vector 1 through n, and returns the sum. This is the sum that we're interested in. So we can now compute the sum for any n. So if I apply it to 3, I get back 6. 1 plus 2 plus 3. If I use 100, I get back 5,050. 1 plus 2 plus 3 all the way up to 100. I can do it on any number. If I compute it on 2017, I get a very large number that's over 2 million. Now, let's say we want to compute this sum for various values of n. Say we want to compute it for 1, for 2, up to 25. So now we're computing 25 sums. Do we write 25 lines of code, one from each n? No. That's what loops are for. Note that we are performing exactly the same task over and over again, except we're changing n. For loops let us define the range that our variable takes. In our example, it would go from 1 through 25. Then change the value as you loop and evaluate the expression every time inside your loop. The general form looks like this. For I in some range, and then the operations that assume I is the value that you're interested in computing on. This I is going to be changing across the range of values. Perhaps the simplest example of a for loop is this useless piece of code. We write for I in the range of 1 through 5, print I, so I see the numbers 1, 2, 3, up to 5. That's what this very simple for loops does. Note that we like to use I in for loops, but it can be any variable. We can use n, we can use a, anything we want. Also note that at the end of the loop, the value of I is the last value of the range. So if I type I after that for loop, I get back 5. And here is the for loop we would write for our sums example. We want to compute the sum for the values 1, 2, 3, up to 25. So the first thing I'm going to do is I'm going to create a vector, an empty vector where I'm going to store the results as I compute them. This is s underscore n. Now I'm going to write a for loop. The index is n, and I'm going to go from 1 through m, which is 25. So inside the loop, I'm calling the function compute underscore s underscore n with the value n. N is the value that's changing from 1 through 25. And as I evaluate that, I assign it to the vector in the nth entry. So we have defined the sum for values ranging from 1 through 25. We can check to see if we did this right by, for example, making a plot. So here I'm plotting n versus s of n. From the plot, we notice that it appears to be a quadratic, so we're on the right track with our formula. To check specifically if we're getting the right answer, we can simply print out the results from our loop and the results from using the formula, and we see that we get the same answers. We can also overlay the two results using the function lines. We first plot the points using plot, and then we add lines using the function lines that show us the predicted values from the formula, and we see that they're right on the dot.